Hello, my name is John Kearton. I'm a radiotherapy physicist here in the Medical Physics Department at QA Hospital, Portsmouth. I'm going to show you today a linear accelerator, LINAC for short, which is used to deliver high doses of radiation to a patient receiving radiotherapy. So behind me, we've got the linear accelerator, which we saw earlier. The main things to notice on the linear accelerator is it's called a linear accelerator because the electrons accelerated in a linear direction along the top of the LINAC there, along the waveguide. Also, you can see imaging panels there. The imaging panels are used to image the patient when they're set up in the correct position. We can do planar imaging, sort of KV imaging, or we can do cone beam imaging, which is like a CT scan of the patient, which is vital to give the correct set of information on the patient. My role here at Radiotherapy Physics is to make sure that the dose of radiation prescribed by the clinician is delivered safely to the patient and to the right area of the patient in order to maximise the treatment process and minimise any side effects to the patient. You can see the LINAC behind me here. So here's the LINAC control area. It's quite a complex bit of kit. The LINAC accelerators, there's 4 LINAC accelerators in the trust at the moment. Very complex equipment, very costly, but they also deliver vital service to radiotherapy patients. We need to make sure that they're delivering the right dose of radiation, so that's where our measurements will come in. So this is the barium true beam linear accelerator that we're going to deliver the treatment on today. I've loaded up a reference patient here, which is what we deliver before we treat any patients, just to check that the machine can actually deliver the treatment correctly and that the equipment we're using to measure the dose of radiation is actually working properly. We do this before we deliver any of our patient treatments routinely. Okay, so to turn the beam on, we hold this button down. It then lights up the second button and then that turns the beam on. So now it's delivering the dose of radiation. You hear the beeping, that's when the dose of radiation is being delivered and checked by the system. In the bottom right hand corner you can see the multi-leaf collimators. They're used to modulate the beam, so they move all the time. The accelerator is delivering the dose of radiation, and they enable very high doses of radiation to very prescriptive areas of the patient, which minimises any side effects and also delivers the correct dose of radiation to the patient. Okay, so you've now seen the LINAC accelerator deliver the radiation dose to the phantom material we've got on the LINAC, so we can now look at the results. So this is the software we use to verify the dose delivery to the patient. So you can see the treatment plan system generated dose here and then the actual measured dose here. And we've also got the differences in the dose delivered in the bottom there. This system enables us to actually put the dose delivered onto a CT scan of the patient so we can see if there's any failures, where the failures are. But you can see on here that everything passes really well and there's no issues with that delivery. So we're quite happy that the dose of radiation has been delivered correctly by the LINAC for this patient treatment.